You know that feeling? You ask your smart speaker to play a song, and for just a beat too long, there's silence. Or your smart doorbell takes that extra second to show you who's at the door. It's a tiny delay, right? But in a world that's supposed to be instant, it can feel like forever. So, what's the holdup? Well, the answer isn't really about the software, it's about geography.
Yeah, it's a super common and kind of frustrating experience, isn't it? You've got this smart device that's supposed to be lightning fast, but it leaves you hanging with that little bit of lag. It's that gap between when you ask for something and when it actually happens that makes you wonder, just how smart is this tech really?
And the reason, believe it or not, comes down to simple physical distance. See, most of our devices, they work by sending a request to a huge centralized data center, what we all call the cloud. The thing is, that data center could be hundreds, maybe even thousands of miles away. Every single command you give has to make a full round trip. So this distance creates three big problems, which you can see right here. First, there's latency. That's just the fancy word for the travel time delay. Second, you gotta picture billions of devices all trying to talk to the cloud at the same time. You get network congestion. It's basically a giant data traffic jam on the information superhighway. And finally, and this is the big one, for some applications like a self-driving car needing to brake, there's absolutely no room for delay. They need to react now, not after a long trip to the cloud and back.
Okay, so if the problem is distance, the solution seems pretty obvious, right? Just shorten the distance. And that is the whole idea behind something called fog computing. It's not about getting rid of the cloud, but about giving it some help right here on a local level.
So what is fog computing? Think of it as a middle layer of computing power. It sits right between our devices and that big, faraway cloud. Instead of sending every last piece of data on that long journey, the fog layer handles all the urgent, time-sensitive stuff right where the action is happening, at the edge of your local network. This is a fantastic way to think about it. The cloud, that's the big corporate head office. It holds all the company records, does the heavy-duty long-term analysis, and sets the overall strategy. But the fog? The fog is like your network of local branch offices. They are empowered to make quick, smart decisions on the ground, to serve local customers, without having to call headquarters for every little thing. It's just faster and way more efficient. So how does this actually play out? Let's break it down. Step 1. Your smart security camera is generating a constant stream of video. Now, instead of sending that massive video file all the way to the cloud, it first goes to a local fog node, which could just be your home's internet router. That's step 2. That node analyzes the video right there, in real time. And only when it spots something important, like a person it doesn't recognize, does it move to step 3. It sends a tiny alert and a short clip to the cloud for you to check out and for permanent storage. All right, to really nail this down, it helps to see fog computing right next to its more famous cousin, the cloud. And remember, they're not rivals, they're partners in making a much smarter system. This chart really lays out the key differences, and you can see how everything just flows from that very first row. Location. Because fog computing is close by, its latency is super low, which makes it perfect for real-time applications. Its whole architecture is distributed, spread out wherever the devices are. The cloud, well, it's the exact opposite. It's centralized, so it's far away, which means higher latency, making it better for tasks that aren't so time-sensitive. And these differences, they give fog computing some incredible superpowers. We're not just talking about speed here. It's about being smart. It's location-aware, so it knows what's going on locally. By processing data right there, it dramatically cuts down on the amount of data clogging up the internet. And here's a cool one. It can even boost security by analyzing sensitive data without that data ever having to leave your local network. Okay, so this all sounds great in theory, but where is this technology already changing the game? Let's take a look at where fog computing is moving from just an idea into a really critical piece of our world. I mean, look at this list. From the cars we're starting to see on the roads to the power that lights our homes, the impact is massive. A self-driving car simply can't wait for a signal from the cloud to slam on the brakes. A remote health monitor has to alert a doctor the very instant a patient's vital signs go critical. In every one of these situations, a delay isn't just an inconvenience, it can be the difference between safety and disaster.
Let's take that smart traffic system. It's a perfect example. A traffic camera using a fog node can actually watch the flow of cars and pedestrians and change the light from red to green all by itself to clear up a jam in real time. It doesn't need to ask the big central cloud for permission. All it sends back to the cloud is a simple summary, something like, hey, traffic was heavy between 5 and 6 p.m., which the city can then use for long-term planning. That's what you call efficiency.
But with any powerful new technology, there are always trade-offs. Fog computing solves some huge problems for sure, but it also brings a few new challenges to the table. And you can see that balance right here. The advantages on the left are pretty clear. You get speed, efficiency, and real-time power. But the disadvantages on the right, they're kind of the other side of the same coin. Managing a scattered network of thousands of little fog nodes is, well, a lot more complex than managing one big central cloud. And putting all that computing hardware out in the world can have a higher upfront cost. Plus, while it can help security in some ways, it also creates a lot more physical points that you need to protect. So, what's the bottom line here? This right here is the most important thing to remember. Fog is not here to replace the cloud, not at all. It's a partner. It acts as the fast, smart, agile front line, while the cloud provides that deep storage and massive back-end processing power. Together, they make a system that's so much more capable and resilient. And as we look ahead, this partnership is only going to get more and more important. This isn't just about making our current tech a little bit quicker. It's about building the foundation for technologies we can barely even imagine right now. So the real question isn't just where we'll need instant decisions next, but what brand new possibilities will open up when instant isn't the exception, but the rule.